Okay, so as I did mention, we are going to use Astra, DataStax Astra today. So that is essentially to fully manage Cassandra database in the cloud without any of the ops. So for those of you, I see some names that we definitely recognize. You're probably already using Astra and you're familiar with what it is. For those of you who are new to us today, this is a really nice, Astra was really developed with developers in mind. It's a way that you can spin up a fully realized Cassandra database in a couple minutes and just go. And we're going to use the free tier. That's the key thing. The free tier is free forever. There's no, you don't have any like requirements or anything like that. You can just get up, create a free tier. That's what we're going to use today to power Cassandra. And, I guess just a couple things about Astra itself. You get a 5 gig free tier. You have multiple key spaces that you can use. So if you have different domains, different things that you're experimenting with your applications in the free tier, there should be plenty of room for you. Again, you don't have to worry about the operations. This is being fully managed for you. All right, so with that, first thing we want to do here is drop a link. So let me actually put that back. And this is going to be the link to the repo that we're using today. And here it is. Let me drop this for all of you. There's that.
Here comes the Discord.
And there's that. Okay, so someone did ask a question about links and such. So for one, I do want to point out the slides are here. So if you go to the slide deck for the workshop and you download that, then all of the embedded links and everything are in those slides in the PDF itself. You also find the links, for things like Astra and stuff, the things we'll be working with today, they're provided for you here in the repo. And before we get started on this part, I do want to just point out this SAI documentation one. This is linking to the DataStax documentation on storage attached indexes. I'll have to admit, I'm really impressed with this documentation. I've been going through all of the FAQ in particular is extremely informational, right? So there's going to be some things that there's a lot of detail that you can get into that we're not going to get into today, like the read and write path for, SAI and such. It's all there. So I definitely suggest taking a look at the documentation on that case. All right. So hopefully everyone's going to that link. And then the first thing we want to do is get everybody going on their Astra instances. So I'm actually going to do this along with you. So if you follow the instructions here, if you go to Astra, use the link here. You just click on that link. It will pop you up to a page that looks something like this. Now, if you've not been with us before and you've not registered, you're going to get a registration page, right? It's going to look very similar. You can use your GitHub or Google or whatever. I already have an account, so I'm just going to go ahead and log in. The registration should only take a moment. And again, this is free, by the way. There's no credit card you have to put in, anything like that. Oh, look, I totally typed in the wrong password.
Free forever.
Yes. Free forever. Sorry.
I'll tell you what I use it for. I use it all the time for just quick hits on, hey, I wonder what this data model will look like, or I want to try this thing.
Yes.
It is so much more convenient than having running CCM on my desktop or something like that. So do it.
Okay. So what I'm going to do is, for those of you who are starting with us in Astra for the first time, I'm going to just run through this real quick, and then I'm going to give you a couple minutes to just do it. It should only take a couple minutes to get your database going. For the rest of you who have been with us before and already have an Astra database, you just check. If you haven't used it in a day, it might be parked. So just go, and when you go to your database, just unpark it. That might take a couple minutes to unpark, and that way we're going to be all ready to go when we get to the exercises. Now, for everybody who's doing this for the first time, and again, this is all in the repo here. Everything I'm going to do is in the repo. So I'm not going to read all that stuff. Like I said, I'll give you a couple minutes to go through it yourself. Just make sure that when you're choosing a database, you choose the free tier, right? It's free forever, free tier, no credit card or anything. Now,
I think a lot of our workshop club members probably already have running instances that are parked.
Yeah, and that's why I suggested to unpark if you are one of those folks. Yeah. But we have enough people who've not been with us before, so I'm just going to go through this real fast. One thing I'd like to point out is in the free tier, even though we do support Cassandra clusters in all three of the major cloud providers, in the free tier, only Google Cloud lights up. If you're looking for something else, then you have to go to one of the paid tiers, but for free, it's Google Cloud. Select a region that's near you. I'm in Florida, so US East is probably good for me. If you're in EMEA or APAC or something, Europe West is probably better for you. And then say configure. Now this part here, as you scroll down, in the repo and read the instructions, you're going to see we've given you exactly the database name, key space name, and such we want you to use. So if you would, just use these values for what we're doing today. Again, if you have already created a database and you've been with us before, just hang tight. I'll show you what to do. But this is just for those who are coming in and creating a database for the first time. Now, outside of what we're doing today, you can create whatever key space names, whatever database names, whatever you want, right? We just ask that for today, you use the values that we provided here, because later on, if folks have questions, it's much easier for us to either troubleshoot or kind of figure out where you are. So again, I'm just pulling these here right out of the page. And then you'll see once you fill all those up, you get the Create Database button, click that, and then you'll come to a screen that looks like this where it says pending. This should only take a moment. Now, let's see. Let's take a look at the chats. How are we looking? Oh, I love Charlie Collins on YouTube. Gotta love Astra and DataStax Studio. I appreciate that. Let's see. Gorab asks, which cloud provider is best among the three? Man, is that a loaded question?
I answered that one with
for you. Well, yeah, in free tier you have to use Google.
Yeah, I was like, yeah, otherwise, because that is a loaded question. But the free tier is always in Google. Because they're our friends and they were like, here, we can help you. So, but yeah, what cloud you use is really, there's a lot of reasons to have that choice, not just because there's lots of things you have to consider before making that choice.
Exactly.
We don't care.
Yeah, that's right. That's right. Okay, so notice here that my status went from pending to this green active, right? That means my database is ready to go. Now, for those of you who had previously created databases, if you go into the database details, and let's say it was Killer Video or the To-Do app, depending, because you've been with us in another workshop, to be able to do this, just go add key space. So when you go to the details section for your database, you'll see add key space down here. Click that, and then start with the key space name. So put in your SA index. And that way you will have the same key space that we have. All right, so with that, I will leave all of you to that just for a couple minutes, just to ensure that you're at a point where you have created, it doesn't have to be active yet, it might take a couple minutes, but just where you've at least created the database. So if you could, once you're at a point where you have a database that you've created, give me a thumbs up in the chat so we know that you're good.
Ooh, we're lucky because Matt Kennedy, who's product manager for Astra, is answering questions in Discord. Yeah. Hey, so when hard questions come, he has the hard.
Yeah, that's right.
Yeah, somebody asked about Spark and Astra, and he was. Yeah, I think he's still typing.
As a matter of fact, Skivis there is actually one of our, Skivis 2000 is one of our regulars. I've definitely seen Skivis in multiple workshops before. Hi, by the way. All right, and again, if your database is good to go, give us a thumbs up. Let us know that you're good. Sorry, Patrick, what were you going to say?
I just said hello.
Oh.
We love our club members, and apparently we're going to have a club in Hawaii.
Yeah, I saw that.
Yeah, all right. Great idea. Except traveling into Hawaii right now is kind of a mess because you have to get quarantined for a month. Wait a minute, this may work out. Yeah. They quarantine everybody.
Wonderful. Okay, I'm seeing some folks pop in those thumbs up. Let us know that you're good. Let's see. Do you just save the name as a key space? Hi, Smitha. How you doing? Do you just save the name as a key space? If you're talking about a case where you are adding the key space, like if you want to add a key space because you already had one before, you just want to grab this key space name, SA index. And then yes, when you paste it in here, you say save, and it will automatically add that key space to your cluster.
Yep.
Yes, you're right, Smith. There are no other details. You literally just hit the save button, and that will then save the key space into your cluster.
I feel like we need to make it more complicated so people believe that it's real. No, let's not do that.
Okay.
Did you hear that, Matt? Make it more complicated.
All right, and Smith, I got it. Wonderful.
All right,
yes, go ahead. Jagannath, go ahead and create the database. So go do that. And even if your status ends up pending just for a moment, we're going to move on and let you all go. Okay, cool. All right, I think we have enough of those. Let's go ahead and move on. And with that, I'm going to pop over to your screen, Patrick. You ready?
Oh, I got to do that.
Yeah, you got to do that.
All right, hold on.
Yeah, let's make sure your screen's all,
Yeah, I gotta get in my sharing mode. Well, now that you can actually hear me.
Yeah, that would have been kind of sad before.
Yeah, so let me go into Skype and say share the screen.
Oh, I got it. I'm sharing.
Oh, it's already.
Yeah, unless. Oh, it's cached. It's cached.
It's your screen.
That's great. It's totally cached. Yeah. All right.
Okay, here we go. See, now that's my other screen.
Ah, I see. There you go. All righty.
Yeah, so people can judge me about all my tabs.
Yeah, he does have a lot of tabs. All right, all you, Patrick.
It's complicated tabs, right? No, there's a connection there. All right. So everyone, we're going to talk a little bit about secondary indexes first, and get you caught up. And we're going to this is more background information, also very helpful as you're building out secondary indexing and what we're doing with storage attached indexing, Cassandra. So let's get moving. So primary indexes, we all know what those are. If you've ever worked with the database, you've used a primary index. And this is when you create a table and you have a primary key, then that primary key with the ID inside of it, that's the primary index or the primary key. Now, what that gives you is automatically that indexing is done, so there's a fast lookup. That's more or less what indexing does for us. And that's something where you do when you do a select off the ID. This is that select statement is valid in both the relational database and in Cassandra. But when you say this ID equals 100, it's an indexed lookup. So you should expect a primary key lookup to always be fast, always be efficient. And it's just basic information that for a database. But when we go beyond the primary index, when we go into non-primary key queries, that's when things start to diverge quite a bit. So in this case, same table, but I want to query something other than the primary key. And this is what gets, I think, this is your first stop on, oh, Cassandra's different. Because when you do this with a relational database, it will do the lookup. Now, it may not be efficient because it's just doing a row query, but it's scanning every single row for the column. But in Cassandra land, you'll get an error. It says, nope, sorry, I can't do that. And you get this, this is the exact face that you will make. Because you're like, wait a minute, I thought those were the database. Why can't I query on a single column? Reasons. But the reasons are now getting into the understanding of what a distributed database actually is and how it works. So in relational systems and distributed systems, especially Cassandra, the layout of data is very different. And when we talk about relational systems storing data, it's usually a DB file that's arranged in row column format, and for good reasons, because that's how you would normally access the data. It's a single system. So if I was to access that country field, that column, it can look up that column very efficiently because it's in a single file and it is arranged in that manner. DB files are arranged in a very fixed manner. Yes, I know that there are other ways to create database files, but this is the most basic. Now, in a distributed system like Cassandra, the row data is actually contained in various files. So when you access a column in that row, it has to go look in all these different files for that, and it could be in random places all over the place. I cannot think of anything more inefficient than basically scanning every single piece of data file on every server. And added thing, we tend to distribute these things around in multiple servers. So when we deploy a Cassandra database, no one deploys just one. They like to go out as a group. So you just start adding in all these complexities that just take it away from how relational databases would work immediately. When you're on a single system, you get to do a lot of great things, like locking and looking for columns is pretty easy. And even a full table scan isn't that hard. But when we start getting into distributed databases like Cassandra, we have all kinds of new considerations, but we still have use cases that need to be served. So let's look at secondary indexing in Cassandra. It's been a bit of a history. Secondary indexing, as we call it, and this is not just a Cassandra term. This is all databases do this, right? I'm not looking at questions. Are you getting good ones?
I think people are listening to you intently, honestly.
That's great. Whew, still listening to me after all these years. So we have when we have the secondary indexing, like early days of Cassandra, it was for finding column data. And so it has been there since the beginning. It just wasn't super efficient. It wasn't efficient at all. It was there to do these arbitrary where clauses or to look up data. But the big problem was that the way that it did it. Every time you did a write to the database, it would re-index everything. And so as you can imagine, on a high write, all of a sudden you get this massive amount of write amplification because your indexes are just churning right crazy. And it gets into this place where if you're running a Cassandra cluster and this is your job to make sure it's stable, your developers can make your life really hard by adding a lot of secondary indexes to tables. And eventually it gets to the point where you have a limit of how many you can add because it just tips over and causes a lot of instability. Instability in a database is just bad. Well, I think we can agree to that, right? So, all right, that was try number one. Then there was this day. It was very exciting. There was a new scheme that was introduced by a team at Apple called secondary attached storage indexing. Storage attached secondary indexing. How did I get that wrong when I'm reading it? So SASE, that's what everyone called it. And SASE was super exciting. Everyone was excited, and there was lots of talks and great energy. Because what it was doing, and this is what was different, it was a lesson learned type thing, but it was definitely a thing around a specific use case. When we look at what that was for, it was for this tokenized text searching. That was what this use case was. And it did certain types of ranges really, really well, like date ranges. However, instead of doing this business where it indexes and reindexes on disk, it introduced this in-memory indexing, so in the mem table. And then whenever the disk flush happened from the mem table, it went with it. So it wrote an immutable index with the immutable data file. It was very efficient on disk in that regard, like for disk usage. But it was like, wow, this is a very usable thing in that regard. However, it wasn't super efficient on the index sizes and how it indexed, and it just created enormous amounts of disk space usage. Like it just sucked up disk like crazy. That was one of the first red flags. And the syntax was built for a specific use case and was really difficult for users to understand. I did a few meetup workshops, webinars on using SASE, and I had to be really careful about how I described to use it because it was difficult you could get yourself in trouble really quickly by like tokenizing everything. Then all of a sudden you're using gigabytes of disk space for 100 megs of data on disk. So
it's a great trade-off, it sounds like,
Yeah, I was like, wait. No, for the use case that it was built for, it was awesome, but it just wasn't generalizable enough. So there was a lot of soul searching in the project. All right, this was a good shot. Do we preserve it or do we learn our lessons and move to the next thing, which is we had a stop along the way, which is DSC search. Now, if you're ever used DSC Enterprise, you know that we've had this search, which is really it's Solar. Solar is great for a lot of things because it uses Lucene, and I don't think there's anything out there that it works as well for indexing text data as well as Lucene has over history. And that's kind of the gold standard. This is what Elasticsearch uses. This has been around for a long time. I'm sure there's some data nerds out there. Well, actually, there's a new way to do it. That's fine, but it's hard to throw shade at Lucene because it does a really good job. So it offered some really cool stuff in a Cassandra sidecar, basically. So it did full text searching, really efficient indexing. It was good on disk, did everything in memory as that. The big downer was that you're running a full Solar engine along with
Yeah.
Cassandra. So, double your JVM joy, right?
And I'll have to admit, like I come from a world previous to here where I was actually using Solar and Lucene along with a relational database actually, and having a Solar cluster, I mean, that was a game changer for us, right? But that was a lot of extra work to do that, and even though what's in DSE search is uber easy to use, it's a really great feature, as obviously as you're saying, right? There's still a lot of stuff that actually has to happen. And so you're kind of really relying on Solar and Lucene to do all the work for you from that standpoint. It's not really native at all.
Yeah, it's a potential. It's a fully standalone system. Solar is a Apache project, and Solar/Lucene. They even have conferences. So, it's a 2-for-1 deal. You get both, but you get all the power. It's just it's a brute force technique. It's sometimes when you need to drive across town, you don't need to take an entire bus.
Now, real quick, Patrick, we do have a set of questions that are relevant to this section. So Smith has got one here. What was the issue with regular secondary indexes? Sorry, I missed that.
What was the issue? The issue was that whenever you write to Cassandra, it would re-index on disk. So every single write initiated a re-index, and all the fun that comes with that.
Okay. Just a second. I can only type and talk at the same time. Yeah, thank you. Yeah, I'll just take my time.
Just take your time. Everyone's waiting. That's
and then another one from Smith. What is Solar and Lucene? And I see that actually Bibin answered Solar is a search engine. Yeah, so the Solar Lucene combination, it's a really powerful search engine that it's an indexing setup where you can add that, whether it's a relational database, you can actually integrate it with Cassandra and such, and you can let it, like if you have documents you need to store, if you want to search through documents, do wildcard, faceting, all sorts of things. It's an open source service for that. Let's see, I saw, Vikrant had, does this happen at the SS table, the mem table level?
Sure. What's the question,
I think Vikrant was asked that at a certain point when you were talking, but I didn't see exactly where that was.
About SASE.
Yeah, I wonder if it's the SASE one. Yeah. So Vikrant.
Yeah, because SASE was indexing. It would index in the mem table, so it kept the data structure in the mem table that was an index along with the data in your mem table, and then flush both at the same time. That made it fast and efficient. It's just when it wrote it out to disk, it was like, I'm gonna eat all your disk space, and that was bad.
Okay, I think that's it for the questions for the moment. So please continue.
Moving on. All right, so that was then. This is now, and I feel like there's a song.
Yeah, I was just about to see if I could pull it up and we'd get hit for copyright.
Don't sing it too well, or YouTube will flag us for a
totally
copyright violation. We have no chance of that ever happening. So this is, and I'm just going to drop this on you. Storage attached indexing makes this happen, and we're going to go through this, but this is just the very basic DDL, and what it means is you now can create just an index like you would in a relational database with easy to use options. You have the cases, case sensitive and normalized, and we're going to go through what all that means in the exercise. But this is what I would normally do in a relational database. I create an index on a table with a column, and then I expect to be able to use that in a very efficient manner. So it's all about this. Without trade-offs. So storage attached indexing has similar things that happen in SASE, where we're attaching the index with the storage file and it's being indexed in memory. But what we're doing is we're giving it the really easy to use syntax that was in secondary indexing. And that was easy syntax. It's just when you add a lot of indexes, you just started getting into trouble. So this is not revolutionary. It's evolutionary. We're moving the needle. We're doing it, advancing the pointer, as we would say. But so what you get out of this is like if I had this very simple table, if you notice the select query, I'm doing a where clause with columns that have never been, they're not a part of the primary key. And not only that, I'm anding them together. That's a very powerful way to start working with your Cassandra data model. And if you've been involved with Cassandra before, you know that a lot of this is just down to denormalization. And wow, as much as I love denormalization and I do it all the time, sometimes that doesn't need to be the answer every time. Am I right,
well,
David?
Yeah, I mean,
Tell me.
we know from a denormalization standpoint, right? Whether you're talking data warehousing, right, or if you're talking about being able to maintain, scalable performance, as in something like Cassandra, that's the way to go, right? Because you're trying to optimize those read operations. But I think anybody who's come from the relational world, and I know if I ask for thumbs up, we're going to get plenty of folks. I mean, any of us in the industry have spent a lot of our time there first. We are used to the flexibility that you get with a relational database and the way that you can flexibly query, right? And I think sometimes people get hung up on some of the initial constraints that you get when using Cassandra in the way that you have to data model and everything. So I think it's like more mental work that's actually needed to denormalize properly, where if you have just a little bit more flexibility, it can take some of that mental load off and help you kind of decrease the amount of tables, right? So I think it's one of those things where you're optimizing denormalization. We are optimizing for that performance. We're optimizing for the Porsche or the Ferrari. You know what I mean?
Well, that's it. I think one of the things that is important about this is it minimizes the amount of trade-offs. Excuse me. If you had, and we got a lot of experience, I've been using Cassandra for 5 years, never used secondary indexes. Because you probably heard all the warnings, like, well, if you're going to use them, here's all the warnings. I hate databases with warnings. I would prefer to use something with a few trade-offs that has predictability to it. And that's what we're trying to add here. Very simple feature. Just use it. Here's how to do it. And it will perform the way you expect it. And here's what you should expect. Not, well, if you do this, then maybe it'll blow up your cluster. What kind of time bomb is that? And it's a mature part of the database. So what it does for you, and if you're using Cassandra and have been trying to avoid indexing for a lot of reasons, this is one of the biggest selling points of doing it right. And this is there's a lot wrapped up in this. Like, for instance, if you look at that red line, which is what SASE did, like I said, the more indexes you wrote, the less disk space you had. And it just wasn't optimized for disk space. That's not what it was built for. Legacy secondary indexing was pretty linear. And it wasn't good, it wasn't bad. It was linear with how many indexes you had. So it was chaotic neutral in that regard.
That's funny.
But it just did a lot of write amplification. But if you look at what SAI has done, and kudos to the team there that built this, there's a lot of focus was put on like the efficiency on disk. And that actually has a lot of ramifications because, let's face it, if it's on the disk, you're going to have to read it. And if there's less, then there's less to read and there's less to index and it's more efficient.
Yeah. All right. So we definitely have a set of questions in the YouTube chat. Okay. So yeah, right. Okay. So Vikrant said, fine with select. How about delete? Will delete with second index as we already denormalize it? I'm trying to understand in the context of where.
Oh yeah, it's the delete and the where clause. Yeah, it should. Any query with a where clause should use secondary indexing. So,
and by the way, he makes an interesting point. As we already denormalize it, so I'm going to pause on that part of your question and Well, because
Why?
we're going to get there in a moment.
Oh, we were going to do it in live.
Yeah,
We're doing it
we're
live.
gonna get there in a moment.
Okay,
We're gonna,
fine.
okay, so we'll come
Okay.
back to the denormalized
All right,
thing in a
all right.
second. Udit has some
I'm
really
gonna-
wonderful questions here. Get ready, Patrick. If Bloom filters tune correctly for a table, then it will help to search data fast. However, in this case of secondary indexes enhancement, do we need to use both in the same table? Does it enhance performance or degrade it? Is the follow-up.
Well, the Bloom filter thing threw me for a loop.
The Bloom filter definitely is going to enhance performance as far as when you're performing the search against whatever data is that you're indexing, right? Because that's going to help cut out any false hits, so you don't have to do extra scans to get to that data. So I mean, Bloom filter is definitely going to help there. But anyway, Patrick, what were you going to say?
I'm going to say no.
No.
Yeah, no, Bloom filters should be completely ignored at this point because Bloom filters are there when you don't know. They're a probability filter, right? And so Bloom filters would be if you didn't have an index on it. And if you have an index, you know exactly where the data is. That's the point. So, yeah, Bloom filters are not. And Matt's in the chat. He's going to tell me if I'm wrong or not. But I don't think Bloom filters have anything to do with it because whenever you do an indexed query, it's going to go to that tree index and say, where's my data, dude? And it'll go directly to it. So yeah, Bloom filters are there really as a last ditch effort to try to be efficient with your data. You know, it's a probability of if you have a lot of SS tables in the system. Wow, we are getting nerdy into
are you watching the YouTube?
No, I'm not. I'm watching my, should I? I'm looking at my slide called density expectations. But yeah, your Bloom filters are a different problem.
Okay, so then we have another one here. Where'd it go? Oh, Smitha says, are custom indexes guaranteed not to go across partitions? I thought this hampered performance if it did. Yeah, that's a great question.
Yes, partition reads are there's to quote one of my favorite people on the planet, Dewey Hydon, there is no magic. If you're doing a multi-partition read, you still need to read multiple partitions. There is a however in there, and secondary indexes already had this. This is just going to be easier to work with. There's an algorithm that tries to minimize how many servers are hit, and that's beyond the scope of discussion here. But you're not going to just scan every single server in your cluster to get the data, unless you get the worst possible case in this algorithm. But yes, if you have multiple partitions, say they're in two different nodes, then you will be reading 2 nodes worth of data.
Yeah,
there is no magic.
Yeah, I would definitely say the way that SAI is going about that is a lot more optimized than just kind of scattering out and saying select star from, right, and having to scan through every single one of your nodes.
Yeah. Distributed systems still have rules, and the rules are okay. I mean, if you break the rules, that's fine, right? Because what does that mean? You're just going to get a slower query. It's not going to break it. But it's just a different set of rules.
Okay. All right. I think that's it for now. So feel free.
I was expecting harder questions.
Feel free.
All right. So here's the next slide, though. So this is right now. Today you're going to use it in Astra, and that's great because then you can get your hands on it and feel it and say, "Ooh, it's very nice." And somebody else's infrastructure, which is even better. But we're actively getting this into Cassandra. It will be added post 4.0. If you're keeping track of what's happening in the project, 4.0 is like tipping on the edge of releasing right now. It's in beta 2, and there's a total code freeze. There's no way we're going to add something as big and gnarly as storage attached indexing in right before we deliver 4.0. So expect that after.
Yeah, and funny enough, the moment that you went to that slide, Tronton in YouTube asked, can secondary index be used with Apache Cassandra? So if you're talking about the storage attached indexing, what we are focused on today, that's exactly what Patrick was just talking about. So it is coming for open source Apache Cassandra.
Yeah, we're it'll be there. It's going through the process, and we will participate, hop into the dev list. Lots of great conversations. We even have some we have some YouTube stuff happening on Planet Cassandra as well. All right, so I'm gonna end with this, and this is where the whole room just goes crazy. How does this change my Cassandra data model? Those of you that have been using Cassandra for a long time, I'm sure this is going to be a big deal for you. Boom! For your new data models, index your columns with secondary indexing before you go down the denormalization path.
Yeah, we just said that. We just said
that means,
yeah,
just said that. So that means starting with a single table, like that user table, and build the indexes on that table before denormalizing into multiple. Like if you're doing a state lookup, country lookup, whatever the normal thing that I tell you to do, try secondary indexing first. And we'll just let that sit there and blow your mind for a minute. What's the reaction on YouTube right now? People are like logging out.
Silence. So I'm not sure if
I'm not sure
if we got the point across, or folks are just thinking about what you just said, Patrick, or what we just said there.
Yeah, maybe they're looking like this dude right now. They're just like, oh my God. All right, so I think we should just move on from now.
Can you please give us an example? Yes, Smitha, we are just about to do that. Yeah, you're going to do this now with us. So that's part of where we're going to get into the hands-on and do the exercises. So this is here. I expected a question like this. So thank you, Jappreet. So do we still need to do denormalization with indexing? So yeah. So notice at the bottom of that. Look at that. I want you to notice a little fine print there, right? Denormalize for SLAs within single-digit millis. So if you have there's a couple different cases to answer this question, Jappreet. For one, if you know that you have tight SLA requirements that require your response times to be within single-digit milliseconds, you're still going to want to denormalize and do that, right? However, if you don't have that kind of requirement, then what we're suggesting is start with a single table, and you can index off of that. Now, it doesn't mean you don't ever denormalize or you never denormalize again. As a matter of fact, if you think about it, we limit the amount of storage attached indexes to 10 per table. You can index whatever columns you want, but you get 10 per table. So imagine we're not saying go create a table with 200 columns and try to index them all. That is definitely not what we're saying. So if you look at those constraints, right, and kind of think about that, will you still have cases where you might denormalize? It depends on your particular requirements. But we're saying for the most cases, and from what we looked at, I actually was asking this question the other day, looking at like from the data that we have, how many people are using Cassandra or DataStax or whatever, how many of them have those tight single-digit millisecond SLAs, and it's like maybe 5%, right? The vast majority of the data models don't. Right. So that's what we're saying. We're saying you can start with the single table and index from there. But again, look at your particular case. Do you need to denormalize? It's going to depend.
Yeah, I think that's good. And I will say this. Hey, Cassandra community, we would love to hear about your use cases as you use this. This is your opportunity to make a splash if you want to be nerdy famous. Get out there. And do some stuff, talk about it. We will get you on a meetup, whatever you want to do, but this is it. This is what we do as a community, is we take things that are pretty well understood and make them better and talk about them and help others. So
okay,
there you go. But now let's do it.
Something. All right, so
David, let's do something.
What we're going to do is go back over to our repo. Now, for those of you who created databases new with us today, by this point, you should definitely have an active status. I do know from some of the comments in the YouTube chat that we had some folks that were adding key spaces. Those, if you added a key space and you added like the SA index one, those should also be in place by now. All of that stuff usually just takes a couple minutes. Let us know if you're having any problem there. So here's what I'd like you to do. If you go down to section 2, right? This is the getting started. Now this, I saw some questions about some examples, please. Now we're going to get into this, right? We're actually going to give you, I didn't.
Are you sharing your screen? Can I get out of here so I can help?
There you go. There we go. All right, that's better. It would help if I had my screen up. Yeah. So yeah, we're going to go down to section 2, getting started with SAI. I'll actually drop you the link for that because I have anchors in here for that reason. So here you go. Let me drop the anchors for you. Boom. And boom. Okay. Oh, wonderful. I saw Brajesh unparked the old DB. Good. Good. And again, if you did unpark a database, that tells me you had one. So all you want to do is go to here, grab that key space name, say add key space, and pop that in and save. Okay, so with that link, you should go to this section. This is going to have you use the CQL's console, the CQLSH console here in Astra. I'm just going to quickly run through it just to give you an idea of what to expect. Then we're going to give you some time to do it yourself. All right, so I'm going to click on my CQL console. Now, the cool thing is Astra will auto-log you in. You don't have to do anything there. It'll do it on its own. There we go. Okay. Now, again, I'm not going to read through everything here. I'm going to give you all time to do that on your own. So I'm just going to kind of pop through some things. I want to take a look at the key spaces I have. I should hopefully have the SA index one that we used before. I'm going to change the context to SA index. So when I execute the following queries, it knows that I'm doing that against my new key space. And again, everything I'm doing is there. I'm going to grab this command. Now notice, for those of you who are new with us and haven't done this with us before, you'll see in every step, right? You're going to see we have a step, and we're going to show you command. That means I want you to do this command, and you should see some expected output. Here's the command, and so on and so forth. So I'm grabbing the command to create the table. This is one of the tables that we're going to use today, this client's table. Something key I want to point out here is notice I have one field in my primary key, unique ID. This is my primary key, is also my partition key, but just this one field, right? Now I'm going to go ahead and insert a bunch of the data into here. And again, I realize that if you're trying to follow along right now, you're probably like, dude, you're going way too fast. It's because I'm going to give you a moment to do it yourself. I'm just running through it so you can kind of see what to expect. Yeah, if you can, because I'm cut and pasting myself. Hey, good for you. Yeah, exactly. Okay, so all we're doing at this point, we're inserting some data into our table. I've got the data. I see with the select star against my table that I've got the data here. Now, imagine what might happen if I tried to perform this query. Select star from clients, that table we just created where last name equals some value. If you remember, if you look at the definition here, unique ID is the only thing in my primary key, right? So in a traditional Cassandra sense, this won't work. And if I try to execute this, Cassandra says, hey, I can't do that. This is where that whole discussion about allow filtering, and for those of you who are new to Cassandra, if you ever see this message, this means stop what you're doing. Don't put allow filtering on your query, right? Matter of fact, that question came up earlier about scanning across your cluster and such. This is a really good way, if you had a billion rows in your table, to, knock over a Cassandra cluster by saying, yeah, select star from where some arbitrary column that's not in my partition with no limit or anything like that. It's going to scan your whole cluster, right? So don't use allow filtering. If you see this message, that is Cassandra telling you, hey, you're doing something out of the range of what you should be doing. Now, here's the point. So now what I want to do is we're going to go ahead and add some indexes. Notice that I'm going to add one on first name, last name, and birthday, right? By the way, this is the syntax. This is it. The SA indexes are really, really easy to use. So I'm just going to we're going to ignore the options. Yeah, go ahead, Patrick. Were you going to say something? Did I hear a Patrick? Where'd Patrick go? Patrick froze. Oh, I lost Patrick. All right, let me get Patrick back. Hold on. Patrick just all of a sudden disappeared. That's what I heard. I heard him leaving. All right, give me just a second. We'll get Patrick back in just a moment. All right. Yeah, all right. Hopefully Patrick... Yeah, Patrick is sleeping. Yeah, he got frozen, didn't he? All right. We'll give Patrick a second to come back on. So, Okay, so again, I'll let you all go through this on your own, but we're just creating these indexes. Ignore the with options for now. I'm going to explain that later. And now if I attempt to perform that same exact query, boom, there. Now I am querying against a column that is not in my primary key, right? By adding in this storage attached index. Now for the rest of them, I'm not going to go through all these. I'm just going to give you time to do it. I do want to point something out here. Notice for these fields for last name and first name where they're string based, notice as we go down, I kind of keep changing the case, right? We'll explain that a little bit later. Okay, so with that, I'm going to go ahead and give all of you, let's say, I'll just give you, 8 minutes, maybe? Something like that. And go ahead and do this on your own. And we'll set some music. There you go. And give us a thumbs up. Let us know when you're done with just section 2. And go. Slick start from Patrick. Oh, Smithy, yeah, I'll increase the font size a tad bit more. Sorry about that. I appreciate you pointing it out. I'll just open this up a little bit so we can... Hopefully that helps. Let me know if that's better for you. Oh, here, I'll give you the site for the timer. I feel like Patrick came back on. Okay. Let's see. Why did
All right. No, he seems to be sleeping. Yeah, no, I'm not sleeping. My internet was tired though.
Now, can you guys? Oh yeah, he is alive. Yeah, I guess they're seeing you now.
It's like some days.
Yeah, the joys of doing these things remote, right?
Seriously.
I like pixelated. Charlie Collins says pixelated silent Patrick.
Not the best
Yeah,
kind.
right. Yeah, Brajesh, you said, do I need to create a new database or can I use the old one? You can, if you've already got an Astra database in place, you can just add a key space. So add the SA index key space if you want to create another key space. You can totally use the one that you have. That's up to you, right? Just understand. I think for all the commands, all the CQL, none of them are qualified by the key space, so you should just be able to use them. But it's up to you. We just usually have you create a specific key space for these workshops, so it's very easy to kind of containerize the work, but totally up to you. Let's see. Okay, and again, don't forget, if you get through all the material, give a thumbs up. I tried not to put too many walls of text in there, but... Oh, Bivin asks, sorry if I missed, where does the SA index store the data will be on each node? It's actually stored along with your SS tables. It's stored there on the individual nodes with the data itself.
That's the reason we have such an unoriginal name.
Yeah.
Storage attached is, so the SS table that has your data, there's an index file right next to it. So yeah.
Yeah. So Jagannath is asking, is SAI available in DSC or Apache Cassandra inversion? I want to say DSC 6.8.3 is when SAI was released. There is a CEP for Apache Cassandra. So if you take a look at the GitHub repo at the very, very top, right here, right? I included that.
Yes, yep. CEP7.
Yeah, I actually put that there. Yeah. So the CEP7. That you can watch that to see its progress and where it is. So the goal of this is to end up in open source Apache Cassandra, right? So it's currently in DSC 6.8.3 and above, and in Astra, and then coming to Apache Cassandra.
Yeah, that's our move. Is we don't want to have proprietary code, but adding a big feature like this is a process in a project like Apache Cassandra. It's a very big and stable database. We don't just throw things into it and hope for the best. Can't do that anymore. Yeah.
Okay, checking some questions. Thank you, Cedric and Alex. I see that. Thank you. Yes, the DSC version, Alex, is 6.8.3 plus. So 6.8.3 and above. Nariana asks a great question, which we are going to get to. In the examples, we have created an index for the where clause columns. Can't we have the concept of composite index? Not composite index. Actually, funny enough, I read that as composite partition key. So not a composite index right now, right? You would create an index for every column that you needed. You can also index in a composite partition key, but like I said, I misread it at first. I thought you were going to say composite partition key. So it is an index per column for right now, no composite. Okay, Wonder, thank you, Shren, completed step 2. So I see a couple of them coming in. Thank you. I'll give everyone just a little bit more time.
Yeah. Couple of questions. Here they come.
Yeah, I'm waiting for Smith. Smith always has good questions, so I'm waiting. What's going to happen? Okay.
I mean, here, question number 1. We had to specify the partition key and clustering columns in order, but now the custom index, we can directly specify column. Correct.
Yes.
That is exactly the truth. Yeah, you're right. With a denormalized table, you're going to have to say partition key, then cluster columns in order, but not anymore. Now, a little modification. If you want to use a partition key, and let's say you have a really wide partition, hundreds, thousands, millions, whatever, like time series would be a good choice. If you want to use a partition key and then an index, the index read is going to be fast. So, or you can do range queries or inequalities, that sort of things. So yeah, I'm going to modify your question a little bit with modify the answer, but you're right. You don't have to have the partition key in a query if you don't want.
Yeah. Okay. Let's see.
I'm waiting for question number 2.
Okay. Correct. Shren, yeah, step 3 is not required just yet. We're going to get there. We'll get there. Let's see. All right. I see more thumbs up coming in. We'll give everybody just a little bit more time for that part. Now, this is very cheery music right now.
I don't have any music. How come I don't have any music?
Oh, you don't get to hear the music. I'm sorry.
Man, what kind of a Joker outfit is this? Data stacks. Jeez.
Now, give us
It's like an open source company.
So Skivvis has a good question over in Discord. If I do a range query, does it get sent to all nodes that contain data for that table? So now you're getting into a little bit of like, when you're in the read path, right? And the answer is it's not just going to go to all nodes right off the bat. It's actually going to go through this iteration where it's going to go to a set. Depending on the result it gets back, it may go to more. As a matter of fact, if you remember, I mentioned before in the documentation, they do a really good job of explaining this. So that's why I included the links in the GitHub repo. But in this write path and read path section, it's down here. Yes. There's this whole section that'll help you understand what's actually going on there. So it really depends on the index. It depends on the cardinality. It depends on like what kind of results you're getting in the data. Are you limiting? There are some variables. It's all well explained here though. So I really suggest here, I'll just drop this to you as well. Actually, I'll give you the spot right to the read path. Yeah, Patrick, were you going to say something there?
Well, I was going to say Smith had the second question in a set of a couple questions. How is this different from a regular secondary index? Aren't indexes also stored on disk? 100% correct. Indexing does happen on disk. That is the way it works. This is something I will make a double point on. Is the difference is how the indexing is accomplished. Yes, it's on disk, but in the case of SAI, the indexing is done in memory and then flushed to disk very efficiently. So it reduces the amount of operation overhead per node. So whereas traditional secondary indexing put a lot of operational overhead on top of everything. So it is not meant to be drastic. You're only going to do indexing on disk.
Okay. All right. So I saw another set of thumbs up come in. Yeah, Smith, I am totally going to talk about normalize in a moment. Yeah. So I'm actually going to go. I stopped at one point because I wanted to get all of you in there doing this. I'm going to go back through and we're going to talk about the individual pieces. Right. And I don't believe that the storage attached indexes are default just yet. I saw Alex. Thank you for doing that. Yes, Narayana, does Tombstone apply? Do tombstones apply for the indexes? Yes, tombstones do apply. As a matter of fact, I want to say that is also here. There we go. I know that there's a tombstone section with this. You know what I'll do is once we get, Narayana, once we get to the next section, here we go. Yeah, it's a little, there are some pieces in here. It's in the read and write path is what it comes down to. It's that same link that I dropped over in the other chat. So let me go ahead and give this to you as well. Oh, wait, wrong. Give me this link. Yeah, this one. I believe that's in the read path. Here you go. Yeah, I really highly suggest, by the way, go take a look at these docs and step through it, right? There's some details that we might be glossing over today that you're going to really get in the docs. Okay, so let's go ahead and now go over the rest of what we're doing here in our queries. So if we remember, by the way, somebody asked why when you leave the CQL console up, does it seem to refresh and you have to go back to your key space? That's because the session token is expiring. It's a security thing. So every once in a while, if you're not actively working in the console, you'll see it refresh.
Hey, David, no one can hear you. Uh-oh.
That was the most random thing. I have a screen in front of my mic. Apparently it hit the button. You can hear me now, right?
Yeah. Boy, this is like everyone believes now that this is a live
There's
thing.
no doubt this is live, right?
I'm losing the internet. You're
Oh my
losing your
God.
microphone. Thank you everyone for bearing
Yes,
with us
we
today.
really, I appreciate the patience there. That was funny. So I will go back.
We run infrastructure.
I will say what I was saying again. That is so random that just happened. So yeah, so so here again, this first one's pretty darn straightforward, right? Where I'm just querying against a column that is not in my primary key. In this second one here, this gets to something that Patrick was talking about before, now where I can use and, right? So I'm saying where last name and first name. And again, this is pretty straightforward, right? You can see now it kind of reduced some of the results I have from the previous one because I've further constrained it. Going down to the next one, now this is where instead of using a string field, we're using a timestamp, right? So birthday was a timestamp. So now I can do an equality against a timestamp, and it looks like Alice is the only person with that particular birth date, so they show up in my data. I can also do a range. I mean, and again, for all of you who have come from doing things with Cassandra before, right? These, unless you were talking like a clustering column or something like that, this is not stuff you could have done at all. So now you can just add these indexes on. For those of you who are new to Cassandra and you're coming from the relational world, you're going to be like, yeah, what's the big deal, dude? Like, I've been doing this for years. Yeah, you're right. So this should feel very familiar to you. Okay, so in this case, now we're just doing a range where, again, birthday is a timestamp. So I'm going to look within a particular range of a year. Now, in this data set, I've only got one user who happens to fit that particular range. But obviously, if I open that up...
I worry that there's a lot of people out there like, this is what a database is supposed to do. So pretty soon, we're not going to say this is new. Right. We're just going to be like, this is the way it works. Leave it alone.
Yeah, exactly. That's too funny. Yeah, but the key thing is to be able to do this at scale and still maintain your response time and your performance and things. That's the trick, right? That's the hard part. And I think that's one of the reasons why it's taking Cassandra, this time to get to this place. Because with a relational database, it might be very flexible. You might be able to perform whatever query you want, really. But how many people here, either on the admin side or from the development side, have had to sit there and wait for, a minute, 40, whatever, dropped, killed the database by trying to perform one of those queries?
Charlie hit it on the head. This is decreasing the Cassandra learning curve.
Yes.
And Charlie,
yes.
I don't know if you saw this, but Stargate is also going down that path with API access. But you may notice that Stargate will rely pretty heavily on a well-indexed database. Go look at the document API blog post on the Stargate website, and you'll probably start seeing that.
Okay. All right. Yes. And Charlie, I just want to repeat that. It makes a dead on point. Decreasing the Cassandra learning curve. Exactly. Right. That's exactly what we're up to. Okay. And now in this last case.
And by the way, he asked about consistency level. Same. I mean, data has to be committed on disk before you achieve consistency.
Yeah.
There's no change there.
Yeah, and actually something really cool about the write path. If you take a look at the write path, Charlie, in the doc, you'll find that when you have an SA index, that index, that flush down, right, the write path, it's actually a synchronous operation with the actual mutation itself. So it's not like a separate thing that has to go off and run or a separate service or anything like that. So it is right there, part of the write path. Yeah, how does it impact? So Vikrant has a question. How does it impact if we keep adding secondary indexes time to time? So you are limited to 10 per table, right? And that's for good reason. As a matter of fact, if you remember what Patrick was showing you on this chart here, right? Notice 1 to 10 indexes with 1 billion rows. So see what happens here? As you increase the number of indexes on a particular table, you're going to increase the density. That just makes sense, right? So we want to keep this within, some parameters that are definitely manageable and those that are going to be consistent. So again, this is why there is that constraint of 10 indexes per table. If that was your question, Vikrant, I kind of think that's what you meant. Like if you just keep adding indexes on, right? So you are limited to 10.
Yeah, it gives you that ability to, it is meant to add a lot of indexes in a cluster. So with the minimal amount of operational overhead, yeah, there is more, but a lot less, and it's manageable and predictable. That's really the point.
Yeah. Yeah. Okay, now on this next one here, notice I saw a couple of you making comments wondering why am I using such strange case, right, in some of the examples. So now this gets into another set of questions I saw. Let's talk about the options. So I think case sensitivity is probably pretty straightforward, right? We're saying, okay, are we going to pay attention to case or not? Now, if you remember in Cassandra, if I am using a partition key or even clustering column and I have, I have different case in my values, I have to know the exact case. I have to do an exact match in order to get that match. So the case sensitivity one is essentially just saying, hey, are you case sensitive or not, right? So what we've done is we said case sensitive false. This means I can use whatever combination of letters I want. Matter of fact, let me blow this one up a little bit so it's a little bigger. Hopefully it's easier to read. So I can use whatever combination of values I want. That's exactly why I was switching between, okay, let's uppercase, lowercase, so on and so forth. I was just kind of illustrating that as we were going through the examples. The second one, normalize, is actually pretty interesting. Normalization, I'll admit, when I first looked at this, it threw me because I interpreted it as being ASCII folding, which it's not. So normalization is a case, and I gave an example here, where there are some characters, I forgot what that one's called, but like if you have like an umlaut or, whatever, NEA is another one where they may have multiple Unicode binary representations in code, right? Some of these have like a handful of different Unicode representations for the same character. What this allows, when you say normalize true, it means you don't need to care anymore, right? The index will automatically handle that for you. So in your code, if say, one iteration of your code passes this value for this and another passes this value, it will be normalized for you. You don't have to translate that yourself. It is not, though, ASCII folding, which is what I originally got trapped up on, which is, by the way, exactly why I put this comment in here, where let's say that you store an accent on a letter. It doesn't mean I can just select with the base, the base letter like an E or something like that. That would be ASCII folding. That is something that's coming, right? But there's a distinct difference. One is the Unicode binary representation, and difference is there. The other one is the case where if I had a name like this, being able to essentially search against it without any of the diacritics. Yeah, diacritics, yeah. All right, let's see. How are we doing on questions?
Cedric is answering them.
Wonderful.
He's doing a good job.
Over it, huh?
Yeah, he's all over it. There was a question about Gremlin, but that was a good typed out one.
Oh, I see. Can we use Gremlin instead
yeah,
of CQL?
Yeah, Gremlin is its own beast in a lot of ways, but it will benefit eventually from proper secondary index. Now, of course,
for those of you who are in the graph world, you're potentially going to shudder when I say what I'm just about to say. If you are interested in Gremlin and you're used to working with graph, there is another option for you. Now, this is not the same thing because this always gets confused. But in Astra, if you go to Connect and you go to the GraphQL driver, I've worked a lot with Gremlin. I love Tinkerpop and all that, and we have a lot of fun there. But that is something that we are usually doing in the back-end part of our apps with the drivers and such, right? And Astra does not currently have Gremlin and Tinkerpop available. However, with GraphQL, if you've not done that before, then you can actually, it's not Gremlin, but it is a graph. It is a graph structure, that a graph query language that you can execute in JavaScript, and it gives you some very Gremlin-y like capabilities. It might be something to explore, right? So take a look at the GraphQL documentation. Again, they are not the same thing. I want to be very clear about that. But it is kind of a cool feature. Okay, let's see. Oh, good question from Vikrant. Can we do something like where this last name like? No, SAI does not yet support like or wildcarding or wildcarding.
That's a full text.
That's a full text search. Yeah. So not yet. All right, let's see. I didn't quite understand.
It does do prefixes though. So if you do the prefix, you can do prefix search.
Oh, okay, good to know. Yeah, thank you, Cedric. Yeah, full text is not there yet. Smitha has a question. I didn't quite understand what the slide where the GIF of a guy blowing his head off was trying to imply.
Yeah, well,
he's not actually blowing his head off. His mind is being blown. It's different. Here's what it comes down to, Smitha. Traditionally in Cassandra, you will hear us shout from the rooftops, and we have been for years. Denormalize, 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 right? When you're creating your data model in Cassandra, you denormalize. You don't treat it the same way that you might in the relational world. And that is, again, to maintain that performance at scale. What that slide was and why his mind was being blown and stuff, I'm sorry, it's going to make me laugh every time, was because now with storage attached indexing, what we are saying is you can actually start with a single table and index from there as compared to denormalizing first. From a Cassandra standpoint, that's kind of a bold statement is what that whole slide was about. I don't know, Patrick, if you want to say any more to that.
Yeah, it's just a different way of starting your data modeling experience. If it doesn't make any sense to you, thank you. Because that means you never had to go down that path.
Yeah.
So yeah, great. Start with the table, add some indexes, see how that works.
That's right.
You. It's great.
Bibin John asks, contain is the same as like, right? Not exactly the same. Contain is going to be something that you're going to use within a collection. So, matter of fact, in the next set that we're going to go to here in a moment, you'll see some examples of it contains. In the documentation as well, you'll see more of that. But that is for you to be able to search within collections like maps and such. But it's not for a wildcard search like a like. Okay, I think... Oh, can we have our own unique IDs instead of system-generated IDs? Hater, you can use whatever IDs you want. The key thing about the types of IDs that we use in Cassandra, like UUIDs, is that they are safe. Like if you don't want to, you can use your own system-generated ones, but in a distributed system, you really want to ensure that they're unique, right? And they're unique across nodes. Here's what it comes down to. If I've got 2 nodes, right? And let's say that I have a request to create a new user and I'm going to generate some user ID. What happens if there's a network partition right then and those nodes can't talk to each other? What I want to prevent against is having a case where both of those users somehow get the same ID, right? Because then when that network partition is recovered and they talk again, oh, now I have a collision. So that's why we use UUIDs. And that's why, because you're going to get more of a guarantee on that uniqueness with the IDs. So yeah, you can use your own generated ones just fine. I'm just recommending that you ensure that they're going to be something that's going to be supported in a distributed system, not like an int or something.
Hey, I want to add in there too. By the way, Bibin, thank you for the big shout out on LinkedIn. That was awesome. I was like, oh wait, we know Bibin. you gave us a really nice endorsement on LinkedIn, so I really just want to personally thank you. Yeah, it was very nice.
All right.
Smitha has more questions.
Yeah, I see that. Well, here, I'm going to answer that in a moment. Let's get to the next section because we've got a half hour left. We still have to do our quiz. I want to give everybody enough time to do this next piece. Okay, so last thing here, just to finish the section 2 up. This example here was just one of those where I was talking about the normalize feature. Honestly, it's kind of a contrived example. It's hard to do here in Markdown. This is better in code where you can actually have those different Unicode binary representations. But again, this is really more one of those cases where if you inserted with one Unicode binary representation, then you could select for the same character at a different Unicode binary representation, and normalize will essentially handle that, and you'll get the character back. Okay, so the last piece here is, with storage attached indexes, it really does increase the flexibility of what you can do with your data model. The point of this whole section was, okay, great, you created your initial indexes, but what happens if at a later time you need to extend that? So boom, we can just go ahead and create another index.
Because boom,
right? Exactly. And oops, I need to use SA index. There we go.
More like a pop. It shouldn't be that big of a deal.
And that's it. I mean, now I can select against something that I did not have available before, where I am using the next appointment column So it's just kind of showing the flexibility. Okay, so Smith's question, in general, well, yeah. Also, is SAI Cassandra specific? Yes. Oh
no.
Oh, you mean okay. You mean what it's doing? Okay.
I was gonna
okay,
let me answer this one. Let's argue about it. How about that? No, SAI is an implementation. Yes, that is Cassandra specific, but secondary indexing is available on almost every database.
Right.
And
yeah.
And that was one of the points I was making. Is that secondary indexing is a common technique of indexing data that is not a part of the primary key of the database. So
I misread that question.
SAI is an implementation of that for Cassandra. But yeah, every database has a secondary indexing scheme.
And then Narayana has another great question. For a large table, only 10 indexes can be created. I think to address the other queries, we may end up denormalizing. Is that true? Yeah, you very well may end up doing that. I mean, at the end of the day, again, if you have those really, really tight SLAs, single digit millisecond response time like requirement, yes, you're going to denormalize then anyway. But yeah, there's no harm. There's no harm in denormalizing some. And again, constraining the amount of indexes to that 10. So the answer is yes, right? You're going to have to mix and match. So if you have some huge table, but you need more than those 10 indexes, then you're going to have to figure out a schema how to kind of break it up amongst multiple tables. Okay. All right. So with that, let's go into the next section. This is going to be section 3. I'll drop you the anchor. Anchor time. Boom, boom. Now this section is going to be just a little different. Reason being, here you go, is there are some new features that have not been released yet to Astra, which are coming this week, actually, or really soon. So if you were to try to execute some of the queries that are in this section in the console, they would not have worked. So what we're doing is we're actually going to use Studio for this next section. So here's what we do. Again, I'm going to walk you through this real fast just so you understand kind of what to expect, and then the instructions are here. First thing, notice this link, this Studio Notebook link. I'm going to copy the link address, right? That's actually just bringing me to a link that's in the repo. I'm going to then hit Studio. That's going to launch, and that Studio's in my tab up here. That's going to launch Studio. Now, this username and password are the username and password. If you started with us today and you created Astra today, you're going to use that index user, index password one, right? That we did, that we created together. Let's see if I do that right. And then hit test. If you had a previously existing database and you had whatever username and password you used there, that's what you're going to pass in, right? So if you had like one of the killer video databases or something like that, you just pass those credentials in. So it's all dependent on the credentials you used when you created the database. Then you should come up to an interface that looks like this. Let me go ahead and blow this up a little bit. Just hit plus, go to import from URL. Both sections 2 and 3 are in here. It uses the same exact numbering and everything like that. So if you just go down to section 3, IoT sensor, then you'll be in the right place. Okay, so for this one now kind of explores some of the other cool options that you have. In particular, you can actually add an index to a partition key column in the case of a composite index. Now, imagine for a moment I only had a single value, like ignore day hour, pretend it didn't exist. If I only had a single value in my partition key and I try to create an SA index on it, Cassandra is going to say, no, you can't do that. It's already a partition key column. Why would you do that, right? In that case, it doesn't make sense. But if you have a composite partition like we do here, you can actually index on your partition key column. So we're going to do that here. Also notice that we have payload is a map. And I mentioned that with SAI, you can index on collections. So you're going to also explore that as well, where now the example below is only going to index on key. But you can index on key, value, you can index on the map itself. Like, again, the details of that are all in the documentation. But this is a really, really cool feature, because now this gets into a question that somebody was asking about contains, where now I can actually start searching within a collection with the storage attached index. It starts to get really, really cool with what you can do. So anyway, I'm just going to go ahead, create my table. Oh, and by the way, I should mention that this example actually comes from a real world IoT example. We're not going to obviously talk about where it comes from and such, but this is actually something that someone really did, right? And then I'll create my indexes. Notice here in this case that my day hour, remember that's one of my partition key columns, but it's because it's composite. And then I'm going to also index on the keys of my payload map. And then we'll insert a set of data. And then now in this case, I just want to point this out. This is a little different in the notebook. This is actually kind of showing a cool feature of the notebook. If I highlight a section and hit run, it'll only run that particular one, right? So as you want to run individual ones, just highlight them and run. So you'll see in here in a case, now I'm looking against device name outside of my primary key. But here now I can also look at one of the columns, but one of the partition key columns as well. So that gets kind of neat. And since day hour is in fact a timestamp, right? Then there's a question here for you. Then now, boom, here's some examples of now querying or within a map, right? This is actually really cool because if you take a look at payload, remember payload was a map. I'm saying contains key. We indexed the keys of payload, and we're looking for speed. And you can see in this example, I can return values directly out of my map. I find that to be really awesome. So anyway, so I'm going to give everybody. Can you tell? It is awesome. Really cool.
This is like, and I just quick plug. I mean, these are the kind of things that I would love to see people doing and talking about in our community.
Yeah.
Like, wow, there's a neat use case, and this is how it made it easier and better. Especially for people who are just starting with Cassandra, seeing the right way to do something is great.
Yes.
So do this as a community.
Let's do it. With that, I'll give you 8 minutes again because we need to leave enough time.
18 seconds.
18 seconds. 18 seconds. We need to leave enough time for the quiz.
Go.
And again, just go ahead and follow the instructions. For those, I dropped the link. I saw some questions for the notebook link. It is right here in the GitHub repo in section 3. If you just hover over this, right click and say copy link address, that'll give you that link, but I did drop it.
Charlie nailed it. He's like the best teacher to excited. I cannot believe they paid me to do this. I would do this normally without even. Oh, wait a minute. I said that on camera.
Oh, they pay you?
Happy they do. But yeah. But yes, I'm a database nerd. I've been writing databases since the 1990s. So I'm kind of sick in the head, really. But it's cool.
Shrin's already done. He's like, complete step 3, done.
Done.
Thank you for telling us though. That's great. Let's see.
Hey, no one likes a flex.
That's
What's
awesome.
up?
All right.
Serena, you need to go around and help everyone else now.
Yeah, Jeopardy is asking so we can index on clustering columns, on partition key columns if composite, and any other column limit 10. Yes. Yeah, you're good.
Yeah.
Yeah, it significantly opens up the possibilities of what you can do. Yeah. Okay, I see Prab gave us a thumbs up. Awesome. Yeah, it shouldn't take too long to get through. Now, I'll admit, these are set up in such a way where you can kind of just press the buttons and go. And it might be a little much for what we're doing today, but I really encourage all of you to take a look at when you get a moment to kind of read through some of the information here, right? I want this to kind of set in that in this particular case, for this IoT use case, right, that it's going to create a partition for every hour of every day for each location. And they have between 1,000 and 10,000 locations and potentially dozens of devices per location. I want you to think about how much data that could be, how much interaction you have in the system. And And then the thing that storage attached indexing does for you is to give you a nice consistent response time at scale, which is kind of the key thing. And it's one of the things that, for some of the other indexing and such in the past, they weren't always very consistent in that way, right? So it's hard to kind of sometimes grok what that means. But I just encourage you at some point to take a read and kind of look at the examples and the implications, if that makes any sense. Okay, so I see some thumbs up. Oh, Smith.
And good feedback about the workshop documentation.
Yeah, wonderful.
Love to hear thumbs up, but also we'd like to hear like, hey, this didn't work for us, because these are GitHub links. They get changed. It's just a PR away from going different direction. And since they're public GitHubs, if you ever just like have a moment and you're like, this is wrong and I don't get it, send us a PR.
Yeah.
Yeah. I know that's always so hard. Like, PR is accepted. All right, but that means I got to make one. But yeah, it's not like we won't say no.
Okay. All right, I see some thumbs up. Let's see.
There's this question on the query engine collation.
Oh, where's that?
It's in the YouTube chat. All right, so I will cover that.
Yeah, thank you. That's Nariana. She asks wonderful questions. Hi again. Yeah, go ahead, Patrick.
So it's actually not the query engine. It's the query engine is the one who is the first step on your, of course, on the query, where it parses it and then figures out the tokening and everything else. It is the coordinators in your system. Now, how it does that is just like any other like quorum query, that sort of thing, is that whenever the query hits the coordinator then makes radiates out all of the requests. Now in secondary indexing, like I said, beyond probably the scope of the 2 hours we have here, but there's an algorithm that is tries to efficiently pick which replicas and things are going to have that data, and then it fans out from there. So it's there is a method to this, but once that data is collected, it's just like any other query where we have to collect all the data from the different nodes. It merges, sorts, and returns. That's what it does, and it's all done in memory. So read performance, yes, there is a hit on read performance when you use secondary indexing. You won't get the same thing as if you do a primary key query.
That's right.
Just like any other index, but your mileage may vary based on the complexity of the index and that sort of thing. Like everything that we do, put it together. You have an SLA in mind. Like, what is your application? What's your budget for database queries? Throw some data at it. We have a NoSQL bench, which is awesome. It does a really good job of making sure that you have a sane data model and you know what to expect. So yeah, use it.
Yeah, I'm glad you pointed that out, right? Obviously if you want the absolute performance that Cassandra can give you, denormalize, right? That's always that core denormalization is always going to be the fastest path. Any index that you add on is going to add some overhead. Yeah.
Write it in assembly and denormalize.
Yeah, yeah, totally. That's great. Let's see. Smith is asking, what are the other ways to deal with the shortcomings of secondary indexes apart from SAI? Use SAI?
I guess I would say, what are the shortcomings? Because that's a multi-pronged answer. Because if the shortcoming of secondary index is a distributed system, then that's where we use consistent hashing and partitions to get faster data. So that's one answer. Other answers are just using complete in-memory indexing, which we are not going to do, but that could happen. There's other than that, I would say get more specific, and we can go into that.
Okay. All right. So I'm seeing. Bibin says this is the best in market now for search without partition key. Is that yeah, I agree.
Copy.
I didn't see a question mark on there, so I'm glad.
Yeah.
Oh.
Yeah, that's going on
That's
Twitter.
funny. Okay.
We're out of time. Out of
All right.
time.
So I'm going to. Yeah. Let's see.
All right. Are we
Yeah,
going to
we're
finish
gonna
up
do the
with
Menti.
prizes?
That's
and
right.
quizzes?
That's right.
Let's do
Oh,
that.
how to
This is a
Ohm
great.
is asking how to drop, index, and recreate with a different map and payload. So I can just show you that real fast. If you're in Studio, if you go to the schema button up in the top right hand corner, pick. I gotta refresh. There we go. Go to my table, my sensor data, secondary indexes. Here are the indexes, right? So if I want to drop one of those, I can just say, real simply, drop index, give it the name, boom, and that's it. It'll drop it, and then I can reload. Now, here's the thing, though. If you have a different map and payload, right? I wouldn't. If you have an existing field and you're changing data, you don't need to drop the index and reload it. As you mutate data, that index is going to be automatically updated, right? So I want to make sure I got your question right, Ohm. If you had a different map, I would just update the map, right? I would just, and your index would be updated. There's no need to drop and rebuild it. Not like you're doing, yeah, no. So if you want to remove the index for some reason, drop it. But if you're just updating, mutating data, you don't need to drop it. Okay, so just to wrap things up, so we have all sorts of other resources for you. Yep. Datastacks.com/dev is a really nice place to go. If you're on the admin path or a developer path, but if you're just looking for like, what do I want to learn with Cassandra, right? Go to datastacks.com/dev. And that'll bring you down different paths depending on what you need. And what's also really cool is that there are embedded exercises right there using Katacoda. Again, it's all free, so there's nothing you have to pay or anything. There is, as a matter of fact, this link down here, this katacoda.com/datastacks, explores a lot more than just SAI that we looked at today. If you want to get into the fundamentals of Cassandra, you want to get into data modeling, you'll find there's Kafka stuff in there. There's all sorts of scenarios that are available. They're all free, right? And of course, don't forget DataStax Academy. And then, as usual, if there are questions we didn't get to today, go to community.datastacks.com. Any questions that you might have about any of this stuff or Cassandra in general, you can always go there. I think at this point, you all have the link to the GitHub repository. And, and you guys beat me to it. Yes, I was going to ask in the Menti, what? Yeah, totally. If I were to nitpick, checking audio video sync, you know what's really funny about that? We do that every single time. And the Patrick audio hiccup earlier, I have no idea how that setting got changed. So that's something I'm going to make sure that in the future I have locked down. So that was kind of funny. But yes, totally. My first session, awesome. And I didn't find any issue as such at this one. Thank you so much. Wonderful. Good. Let's see what else we have. And by the way, you can be, I love the good stuff, right? I love the good ones. But if you have any constructive criticism, feel free to put it in here as well. Alrighty.
Well, and if this is your first one, don't be a stranger.
Yes,
we would love to see you back.
Yes.
As you know, we have great friends. We have millions and millions of friends worldwide. Yes. And you're one of them.
Okay, so the question that so many folks are always waiting for is, how do you get the voucher? Right? So Jack, can you drop the voucher link, please?
He did.
Did he? Oh, he did. Oh, yeah. There you go. Oh, he didn't put it in YouTube though. I'm gonna beat him to YouTube.
Jack,
here,
He did it twice. He did it 3 times. Because don't miss
Here
it.
Here you
right?
go. Boom. Here is. I'm gonna drop the voucher links in YouTube. I beat you, Jack. Haha. So there's the voucher link. So go ahead and just click on that form. The form will eventually expire. So you do need to get in and fill it out. All you need to do is put in the email that you use to register for the event, and you'll get a voucher. There is another path to get the voucher. I mentioned it in the beginning. I'll mention it now. I'll actually just show you real fast because we have, we're over by 1 minute, but I'll have you done here in literally 2. So if you go to Academy, and within Academy, am I already authenticated? Oh, okay. Let me do it this way. Here we go. Right. No. I can't type Academy. I keep doing CA. Academy. There we go. All right. If you go to academy.datastacks.com, this is the other way to do it, right? And I do this. Yeah, that one.
Shameless plug. I just put my I just put a link in Discord. If you're, I've been talking to a lot of users about your use case, and if you would love to just spend 30 minutes and tell me about yours, I would love to talk to you. I've been doing about 5 of these a week, and what do we do with them? I mean, sometimes I just get to know you, but sometimes we find good places for meetups, and we find places for maybe you want to be involved in one of our workshops. I don't know, but blog posts, or just maybe you can help out with somebody. Consider me like the router.
Yeah, and Patrick, can you drop that in the YouTube as well?
I will do that right now.
If you don't have it, I can do it. But
I got it. And here's my Calendly link, or it's not Calendly. It is x.ai, but same thing. But yeah, just find a time and let's talk about your use case. And I would love to. This is a shameless plug, of course, but yeah.
Okay, and then so for the Academy piece, once you log in to Academy, you'll see this admin path and a developer path. If you click on either one of these, you'll be presented with a set of courses. Complete all of them. Once you have completed one path, then you can email academy@datastacks.com, let them know which one you've completed, right? And you can get a voucher for that. And the cool thing about it, these vouchers, between what the form does and what these do, will give you 2 attempts to actually take the real certification. By the way, that real certification is right here. So if you click on this, this will actually give you the information that you need. Matter of fact, I guess I should drop the certification here. I will also give you a repo, another repo, is another workshop. By the way, we're doing it next week, I believe, the Cassandra certification one. For those of you who are interested in Cassandra certification, here, boom, we'll talk about all of this next week. But this will bring you through all the information that you need. Really, what I want you to know, though, is that if you complete either one of those paths, the full paths, and complete all the courses within them, you can get yourself a free voucher as well. And somebody asked, if you're new to Cassandra and you don't know which certification to pick, it depends. If you want to administrate and operate Cassandra databases, the admin path is for you. If you're a developer who is, or an analyst or somebody who is using Cassandra for its data, and you're going to be working with applications, the developer path is for you, right? So it really depends on what your goals are. All right, with that, I think that's it. I was just looking for questions. Awesome. Thank you, everybody. We really appreciate you being here today. For all those who've been joining us over time, thank you so much for continuing to join us. We really appreciate it. And by the way, when we get that feedback in the Menti and stuff, we've been taking that to evolve our workshops and hopefully making them better. For those of you who are new with us today,
tell a
friend, right? And also, don't forget to subscribe, right? If you go to the YouTube channel,
we need subscribers.
If you go to the YouTube channel,
good call.
Where you view the video, and you hit subscribe. Oh, wait, I'm in a different mode. You won't see it. You're going to see it in an outro in a second. But if you, you hit subscribe and you click the bell, then you get notifications every time we're doing a new workshop. And with that, thank you, everybody. We will exit out. We'll see you next time. And take care. Have fun with your new indexing. And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.